Okay, we are moving on to an extension of all the properties together. All the properties together, the associative, commutative, distributive, identity, zero, allows us to do these things called simplified algebraic expressions. That's what you're going to be able to do today. You've done it before, but we bumped up the rigor with negative signs and distribution. The main topic is like terms today. We have to remember that you must combine only like terms. So you need to know what the vocab word terms is. Terms are part of an expression. They are what is being added or subtracted or multiplied or divided. So 4 is a term, 3x is a term, y is a term, 7 is a term. All of those are terms. So this expression, 4 plus 3x plus y plus 7, has 4 different parts, 4 terms. Okay, so terms are the parts. Like terms have the same variable connected, or no variable, or they're constants. So like terms would be 4a and 6a, 5b and 4b. Those are like terms. Same variable. To the same power as well. Sometimes 7th graders mess that up. If you have 7x squared plus 3x plus 4x squared, the only like terms that you have on that expression would be the x squared terms. You can't combine all of them just because they have an x. They have to be the same power as well. Okay, coefficients are the numbers in front of the variable. The number in front. So I'm just writing a list of some terms here. My coefficient would be the 5, not 5x. It's just the number. So my coefficient would be the 5 here. My coefficient on the second one, just the 3. My coefficient on this 4ab would just be the 4. A coefficient is the number that is sticking to a variable. In constant, a constant has no variable. It is constantly the same thing. A variable changes, a constant stays the same. If I had 3x plus 4, 4 is my constant. It doesn't have anything connected to it. Just as an example. Okay, moving on to the actual application of identifying parts of an expression. Notice I'm talking about expression, so you're not going to see any equal sign. An expression does not have an equal sign. So, given the following, and today in your work, you're going to be given an expression such as the one above, and you are going to have to identify what are the terms, what are the like terms, what are the coefficients, and what are the constants. Yeah, it's just, and what I would do is just make a little chart. I don't know if you want to go as long as my chart is, you could go vertically to list it as well. So the terms on this top expression, let me just do it down here. Let me just do the first example first. So let's go. Terms are like terms. See how I'm organizing it? Coefficients, coefficients, and then constants. Alright, now you can't combine them yet. If it says list all of the constants, list all of the like terms, don't combine them, you're just listing the terms. So here are my terms. Well, first thing you need to do is turn everything to plus and negative. Because my constant there was at 1, and that's what a lot of students think. It's actually a negative 1. So my terms are 3a a 2, a 4a, and a negative 1. They're all the parts of the expression. Those are my terms. I have two sets of like terms. I have my a's, I can combine those up, and I have my constants are also alike. So my like terms would be 3a and 4a. Then a separate one would be 2 and negative 1. Both of those, I have two sets of like terms there. Coefficients, number in front of a variable. Number in front of a variable. So I have two coefficients. I have a 3 and a 4. My constants have no variable connected to it. So I have my 2 and my negative 1. Okay? So that's one of your learning targets. You have to apply these algebraic terms, or vocab words I meant. Terms, like terms, coefficients, constants. You need to know what all of those are. Let's do one more. Terms, like terms, I'm going to abbreviate. Coefficients, COF, I'll call it COF. And constants. Constants I'll write out. I don't know why. Before you start identifying the parts of the expression, please make sure everything is plus and negative. So I need to change this -3 to plus a -3. Now I have three terms. I have a -4m, a -10m, and a -3. Those are my terms. My like terms, I only have two like terms. That would be -4m and -10m. I could combine those two together. Coefficients, what are my coefficients?
-4 and 10.
Yeah, let's hear more. What are my coefficients? -4 and -10. They're the numbers in front of the variable. And what's my constant? -3, only one little constant. Hey, what happens what are my like terms here? None. And you're going to have that in your homework. So you would just say under the like terms part, you would say none. Okay, so there's going to be some none in your homework today. Okay, moving on. Now knowing the vocabulary word, we can apply it to actually simplify. So simplifying like terms. Notice now I have the term. You understand term is parts of an expression, excuse me. Okay, if there is nothing in front of a variable, it is 1. You remember that. You also need to remember if there is a minus sign, you need to turn to plus and negative. I'm going to give you a minute to catch up. Okay, so we're going to go ahead and simplify these next expressions. The first thing I do is look to see if I need to change anything to plus or negative. In this first example, I do not. I'm going to put a 1 in front of my x there as a coefficient, my vocab word. And then I like to use the lines to combine my like terms. 1x and 4x is 5x's, plus 4 and 8 is 12. And that would be my simplified expression. Because you can't combine your 5x and 12 because they are not alike. Next one. I'm going to plus a negative for that negative s. I have 3s and negative s that are alike. And I have 4f and 3f. So it would be 3 plus a negative 1 would be 2s plus 4f plus 3f's are 7f's. And that is my simplified expression because I cannot combine s and f. Ooh, look at more negatives. And I think this will be the last one that I showed so we can move to the distributive ones. I'm going to go through and plus a negative. Now combine. Oh, look, I got to combine that 3 over there too. And then I just start combining my like terms. So negative 4 and negative 6, that turns to a negative 10. Negative 10 plus 3 is negative 7x plus 3 and negative 5 is a negative 2. And then I usually rewrite it as negative 7x minus 2. All right, we can just go ahead and scoot to that next page. Okay, next application is to apply combining like terms with the distributive property. The most important thing to do is to distribute. That's always what you do first. So the first thing you do is distribute. And then combine like terms. Second, CLT, combine like terms. All right, so first example, I'm going to distribute my 4 to just the first set of parentheses because that's all it's sticking to. 4 times 2 is 8x plus 4 times 3 is 12 plus the negative 2x. Now I can combine my 8 and negative 2 and that gives me 6x plus 12. And that's my simplified expression. Okay, this is really a negative 1, and then I'm going through and I'm plussing a negative. I'm going to distribute my negative 1 just to the parenthesis, not to the negative 9. Not doing it because it's not inside the parenthesis. So it's negative 3x plus 4 plus a negative 9. And then I can combine my 4 and negative 9. And you get negative 3x plus a negative 5. Favorite is that way. Negative 3x minus 5. I'm just going to skip to that last one because it's the most relevant. So I'm going right here. I'm doing this one. So I'm changing everything to plus a negative. If you don't, I bet you're going to make a mistake if you don't change it to plus a negative. I have a funny feeling. Distribute. I'm only distributing the negative 2. 8 plus a negative 6x plus 10 plus 2x plus a negative 12. Let me repeat what I did. I distribute my negative 2, so negative 2 times 3 is that negative 6. Negative 2 times negative 5 is that positive 10. And then I just rewrote everything else. Now I can just combine my like terms, so I have an x and my constants. So I'm going to combine this and this. Negative 6 and 2 is a negative 4. Now I got to combine all of my constants. 8 plus 10 is 18 plus a negative 12. 6.
Yeah, that's what
And that's it. And that is my simplified expression. So just to summarize, when you have these longer problems that you have to simplify, the first thing that you want to do is distribute and then combine your like terms. So I distributed and then I combined my like terms was my second step.